I'm just going to go through a type of question for you, and then I'm going to look at some further application. All right, so let's say that we've got a shape like this. Now, you had some shapes like this yesterday. I just want to show you the easiest way to do this. Some of you were trying to make weird triangles out of this. Obviously, we want to make triangles out of a shape like this. It doesn't matter how many sides it has. It's the same idea. So I'm just going to put a dot in the center. And then if I draw a line to each corner, aren't I making a whole bunch of equal triangles? I mean, if I could draw straight lines, they'd be very equal. Oh my gosh. Leave me alone. Oh, wow. I just don't have the capacity for straight lines. I don't know why. All right. So if I have something like this, how many degrees are in a circle? Okay, so can't I break it down and say how many degrees are in each bit? So how many triangles have I got? 6. Okay, I've got 6 sections. Okay, so that makes each little one 60 degrees, doesn't it? 6 lots of 60. So what I'm going to do is I'm going to take the bottom triangle. Actually, let's just make a triangle. Hey. All right, ta-da. All right. So let's say that this is the bottom triangle. So this is 2 meters and this is 60 degrees, correct? If I want to find the area of this triangle, or let's say I want to find the area of this shape, what kind of triangle is this? Isosceles, isn't it? These two must be the same because they're both going out to the edge. So what kind of triangle can I turn this into? I can turn it into, no, right angled. I can turn this into 2 right angled triangles. So what does that make? So let's draw another triangle. So let's just say that this is half of it. So what is this length down here? 1 meter, because it's half of this. And what is this angle up here? 30 degrees, because it's half of the angle. And I need the height of this triangle, don't I? How could I find that? TOA, good, right. So using SOHCAHTOA, this is a right angled triangle. I have one unknown. So I'm going to say that this is tan because this is my adjacent and this is my opposite. So then I can say tan of 30 degrees equals 1 over h. So then I would bring h tan 30 equals 1. So then h equals 1 over 10 of 30. Someone type that into a calculator. 1 over 10, 30. 1.7. 1.7. All right, so this is 1.7 meters. So what is the area of this triangle? Half times base times height. Just, well, 0.5 times 1.7. So what's half of 1.7? All right. How many of these triangles are in this shape? No. 12, right? Because I just found out 1. So this is what I found out. And there are 12 of those. So if I times this by 12, I will get the area of the entire shape. Make sense? So break everything down into smaller triangles. It'll make your life much easier. If you've ever got an isosceles triangle, make it into 2 right angled triangles. Then you can think about using SOHCAHTOA because you have only right angled triangles. All right, I'm going to give you another example now, but guess what? We're going to make it 3D. Yeah. All right, so I promise you there will definitely be a question exactly like this on your exam. There is always a question exactly like this on your exam. So, oh, that is a straight line. Oh my gosh. Shut up. All right. All right, so we have a 3D box. Leave me alone. All right. So this is our 3D cardboard box. I'm going to say that this is 2.4 meters long. It is 1.1 meters deep and it is 1.8 meters high. All right, is it? We're about to find out. So I am also going to label corners. So this is going to be A, B, C, D, E, F, G, and H. Are we just saying the alphabet now? What's happening? Let's pick another color. All right. I want to know the length of AG. So if you think about what I'm asking you to find, this is a 3D line from the front corner to the back corner. This is going to require some more information than we currently have. So I need to find this line, and if I make a 3D triangle, it's going to be this. And that is my right angle. This is a 3D triangle, and I currently cannot work this out without more information. Neon, what do you want? You can use Pythagoras for this, absolutely. What I need to do, though, is work out I need to work out AH first. I've got GH. I need to find AG, but I do not have AH, right? I'm going to call this X, and I'm going to call this Y. I'm just going to color code them to help. So to find X, I'm going to use this triangle. If I was a good drawer, that would be a 3D, that would be a right angled triangle. So to find X, that means X squared equals 2.4 squared plus 1.1 squared, right? This is my Pythagorean section here. So then X equals the square root of that. Someone type that in for me. Oh, that should be 1. Sorry. I could if I wasn't so lazy. All right, so X is 2.6 meters. Now that makes sense to me because it's longer than 2.4, right? This has to be the longer side, so I like that. All right, now we need to find Y. Now I have this as my Y triangle. So I'm going to say Y squared equals, well, X squared, which is 2.6 squared, plus the height, which is 1.8 squared. So Y is the square root of all of that, which is, someone type that in. .1 meters. 3.2? 3.16. Okay, let's do that. 3.2. All right, so Y is 3.2. This is a 3D line. Now, they will often also ask you for an angle. So let's just zoom out a little bit so I've got some more room. So they will often ask you something like, what angle, let's just start over here. What is the angle made by the plane? Well, actually, let's not say that. I'm going to give it to you slightly differently. Made by AG to the base. All right, so they might ask you something like that. I want everyone just to think in their heads for a second, which angle are you being asked to find? So have a think. I'm going to draw it in a second. I want you to see if you can pick which angle you are actually being asked to find. That doesn't make any sense. X is a line, not an angle.
Oh, angle.
Not everyone is looking at the board. Everybody should be looking at the board. Which angle am I asking you to find? What is the angle made by AG to the base?
Okay.
All right, it's actually this angle here, and it's part of my 3D triangle. It's not this to AD. A lot of people accidentally find this wrong angle. It is part of my 3D triangle because AG is a 3D line and it needs to go to the base. Do I have enough information to find this? I do. Do I use sine, cos, or tan? It doesn't matter. I can use anything. I have all three sides. So it makes no difference to me whatsoever. What do you want to use?
Oh.
All right. Sine of the angle equals, what's the opposite side? 1.8. What's the hypotenuse? 3.2, right? We said this is the hypotenuse. This is the opposite. And then how do you find an unknown angle? Inverse sine. So type that into a calculator for me.
$34.99.
34.2 degrees. All right, that sounds good to me. All right, so 3D things, there's nothing new here, but they are making you apply your knowledge to 3D spaces. Occasionally, they may be non-right angled triangles, but most of the time they are right angled triangles. Mostly the non-right angled stuff is 2D stuff that they're asking you to find. All right, that's it. Let's keep going. Do you want to say anything before I stop?
Guys, like and subscribe. New videos every week. Bye-bye.